Welcome to qnawire.
In problem 52, we're told that a person sees distant objects well. However, their near point is 45 centimeters instead of the usual 25 centimeters, and this person intends to wear contact lenses to correct their vision problems. And with wearing contact lenses, we know that the object to eye distance versus the lens to the object distance is the same. So in other words, we're neglecting the distance between the eye and the lens itself. In part A, we were asked to find or determine whether or not this person is nearsighted or farsighted. Since this person sees distant objects well, and their near point is beyond the usual near point, then this person is farsighted. And if you read chapter 34, the section that deals with the eye, there you'll find that the farsighted eye tends to diverge the bundles of parallel rays too much, so that an image can't form properly on the retina. So you need a converging lens to fix this problem or to compensate for the diverging bundles of rays. And then in part C, we're asked to find the focal length and the power in diopters. So we'll use equation 34.16. Which tells us that 1 over s plus 1 over s primed is equal to 1 over f, where s is the object distance, s prime is the image distance, f is the focal length. And so what happens here is that we want that when a person is looking at an object that's close, let's say at the usual 25 centimeters, we want to correct that near point from the far distance, 45 to 25. So you want the object distance is 25 centimeters. And this person, their near point is 45 centimeters. So when they're looking at an object close, they can't focus very well unless it's farther out at 45. So we want the image that when they wear the lens, that we want the image that's formed to be at this 45 centimeters where it's comfortable for them to see. So we'll set the virtual image to be at the near point. So essentially the object distance is set to the normal or the usual near point, and the virtual image distance, I should put a negative sign there because it's a virtual image, is at the actual near point of this eye. And that is equal to 1 over the focal length, which I believe we're given, but I forgot to, no, which we need to find, sorry. So that's 1 over f. From this equation, you can find that f is equal to s primed over s plus s primed. And we know s and s primed, so f is 25 centimeters times minus 45 centimeters divided by 25 centimeters minus 45 centimeters. And that is equal to 56.25. centimeters. And let's convert this to meters because we'll need to do that when you measure stuff in diopters. So that is equal to 0.56 meters. Now to convert to diopters, you just take the reciprocal of F in meters. So that is 1 over 0.56 meters, and that is equal to 1.78 diopters.